Question 3. A person throws a rock vertically downwards with an initial speed of 3.2 meters per second from a height of 1.5 meters above the ground. Air resistance is negligible. What is the speed of the rock just before it hits the ground? This question tests our understanding of motion under constant acceleration, particularly how to use the equations of motion to relate velocity, displacement, and acceleration. This is a problem that falls under motion. What do we know? We know that equations of motion relate velocity, displacement, acceleration, and time for objects moving with constant acceleration. These equations allow us to calculate unknown quantities when some values are given. We also know that all objects near the Earth's surface accelerate downward at about 9.8 meters per second squared when air resistance is negligible. This acceleration is the acceleration due to gravity, usually represented by g. Let's get into the solution of this problem. First, we identify the known quantities from the question. The initial velocity, u, is 3.2 meters per second downward. The height, which represents the displacement to the ground, is 1.5 meters downward. And the acceleration due to gravity, g, is 9.8 meters per second squared downward. Next, we choose a suitable equation of motion. Since the question asks for the final speed and does not involve time, we use the equation v squared equals u squared plus 2as. Here, u is the initial velocity, a is the acceleration, and s is the displacement. Now we substitute the known values into the equation. V squared equals 3.2 squared plus 2 multiplied by 9.8 multiplied by 1.5. First, we calculate the square of 3.2. This gives 10.24. Next, we calculate 2 multiplied by 9.8 multiplied by 1.5, which gives 29.4. Adding these together gives v squared equals 39.64. To find the final speed, we take the square root. The square root of 39.64 is approximately 6.3 meters per second, so the speed of the rock just before it hits the ground is about 6.3 meters per second. This is our final answer. What did we do? We started by identifying the known quantities from the problem, the initial velocity, the height, and the acceleration due to gravity. Then we chose an equation of motion that allows us to find the final velocity without involving time. After substituting the known values into the equation, we simplified the expression and finally took the square root to obtain the speed. A helpful tip when solving problems like this is to choose a direction as positive before using the equations of motion. In this problem, downward was chosen as the positive direction. Because of this choice, the initial velocity and the displacement are both positive since they act in the downward direction. So, the first thing to do is to choose a relevant Suvat equation. The next thing to do is to choose a direction that you assign positive. Let's finalize by looking at the relevant ideas for this problem. The equation v squared equals u squared plus 2as allows us to find the final speed without needing the time of motion. And when using equations of motion, it is very important to choose a consistent positive direction so that all velocities, displacements, and accelerations follow the same sign convention.